Hello everyone, welcome back to our channel. Today I want to show you how can we turn mesh into a surface for our site model. So first of all, I am going to isolate those two surfaces. One is in mesh, which is our original one, and one is a NURBS. And you can see that the NURBS preserved all the features from the mesh. At the same time, we can edit this NURBS easily in our Rhino environment. One thing I want to emphasize is that this NURBS surface is one continuous NURBS. It's not a poly surface. So that is actually very useful in a lot of cases. And let's take a look. How can we turn this mesh into a NURBS? First, I'm going to delete this NURBS, and then I'm going to open Grasshopper. I'll bring this mesh into Grasshopper. And then I'll create a bounding box around it. The next thing I'm going to do is I'm going to use deconstruct wrap to get the faces from the bounding box. And I want to find the bottom one. How can we do that? First, we can get the centroids for all the faces. And then we can get the z value of those centroids. And then all we have to do is find the surface with the minimum z value here. That's also very easy. We can use a sort list, bring that value in. So the first number in this list is the smallest number. We'll get that first number, which is also the smallest number, using list item. And then we can use member index to find the index of the item in the original list. It says 4. Then we can use list item to get that face, which is this one. So now I can hide everything else except the mesh and the bottom surface. The next thing I'm going to do is I'm going to find the edge of the bottom surface. I can go to surface, wrap edges. This one gives us all the edges here. I am going to get the first and the second edge using the list item. So this is the first one, and the second one should have index 1. And then I will try to get the length of those lines. This one and this one. Because of the division on the meshes are about 10 to 10 grid. So we're going to use that number to determine how many divisions we are going to apply to our lines also. I'm going to hide everything again. So I will use division. And the other input is 10. We get 44.5 and 35.98. And then we will turn those floats into integers. The next thing I need to do is I want to divide those curves. I will bring those curves in. And also I will use this integer to divide them. Now we have got those points on two lines. So the next thing I want to do is I want to use those points that I'm highlighted, create a set of vector. The first vector is from the first point to the first point. It's not moving at all. The second vector is from the first point to the second point. The third vector is from the first point to the third, so on and so forth until the end, so that we are creating a vector between the first point and the last point. Let's go ahead and do that. We're going to use vector 2 points. The base is always the first point. This item is the first point, which is right here. I'm going to bring that in, and the tip should connect to the whole list. So we have created tons of vectors. Let's take a look. We have created 37 vector, and as we imagined, the first vector is 0, 0, 0. It means it's not even moving, which is great. We're going to use those vectors to move those points. What I'm going to do is I'm going to use move, and those are the points we want to move, and those are the vectors. Let's take a look of the data structure. If we just connect them like this, you will see that this is what they are doing. They're not moving the first point, they're moving the second point to here, they're moving the third point to here. That's not what we want. We want to get a grid of points. So we have to change the data structure here. We can simply graft either of those inputs. The data structure looks very confusing right now, so I'm going to simplify it. Now we have one list that has 46 sublists inside, and each of those sublists has one item inside, which is 1 point. And this input is a flat list that has 37 items inside, which is great. So we're going to simplify this one also. So the output is a list that has 46 sublists inside, and each of those sublists has 37 items, which is great. So the next thing I'm going to do is I'm going to move those lines to the ear. Give it a Z value, like a big one. Make sure that all the points are higher than the top of the surface. We can confirm that using the front view. So all the points are above the surface. This is very important. The next thing we want to do is we want to make connections between those original points and the points has moved up to the ear. Now I'm going to go to intersect and find this mesh and curve intersection. Those are the curves and the mesh is the original one. So now we have created all those intersections. So I'm going to hide everything except the original mesh and all the intersections. So we can see that we have find the intersections between all those lines that we have just created and the mesh. And let's take a look of the data structure. In this list, we have 46 sublists, and each of those sublists has 37 sublists. We do want to keep the sublist 0 to sublist 45 data structure. However, we do not want to keep the sublist data structure. How can we do that? Well, we can use path mapper. So now let's take a look of this new data structure. In this new data structure, we have 46 sublists, and each of those sublists has 37 items inside. So we get rid of the last layer of this data structure. That's exactly what we want. So all those points on the same column or the same row are in the same sublists. That is great because we can use this to create NURBS curves. So now we have created a curve using each of those sublists, and that's exactly what we want. Now let's hide everything else. And then we can use a loft to create a NURBS surface using those curves. And it's not working. Why is that? Because it still has a nested list inside. We have to flatten all the data here. Now we have got it, and then I will bake it. Now we have created a surface out of the original mesh, and let's take a comparison. This is a NURBS, this is a mesh. You can see that they look completely the same, except that this is a NURBS surface that we can change it very easily. For example, I can select all the points here, make them more dramatic. They look a little bit edgy just because of the display mode here. It's actually pretty smooth. We can confirm that by creating the contour lines around. I will just select the surface, type in contour. I will go to the front view, select the base plane, and select the direction. Now you can see that the contours are actually pretty smooth. That means the surface is actually very smooth. And also we can trim and split the surface very easily. For example, I can trim it. And you cannot do that easily with mesh. And how can we fix the display mode? All we have to do is just click options and then go to mesh, click this drop down, choose smooth and slower, and hit OK. Now we can also switch this to rendered, and this should solve the problem. So again, you can see that this side is very smooth. It is a perfect NURBS surface. In some cases, your site is not a perfect rectangle. So you have to find the smallest rectangle that can fit in underneath it. For example, if your site looks like this on the top view, what you have to do is you have to find a rectangle that's completely within the region of the circle on the top view. And then you can use the same method that we have talked about today. Hopefully this is helpful. Thank you so much for your attention, and I'm looking forward to see you in our next tutorial.